In this unit, we're going to look at periodic motion. And what periodic motion is something that happens on a regular basis. It repeats itself. So a really good example is I've got a pendulum here, and I'm going to let this pendulum swing, and what's going to happen is it goes over there and it comes back, and it comes back again. If it doesn't hit the desk, it keeps moving in a regular pattern. So it moves over here, then it swings back. And that is periodic. It comes back periodically. Very similar to the periodic table over behind my shoulder. Periodic table, certain patterns happen periodically with the elements, and that's where that comes from. So periodic refers to things that happen on a regular basis. Okay, so when it goes from here over and back, and it gets to the same place, that is referred to as one cycle. That is one repetition over, back, and you're back to the same starting place. Pendulums are very good. We don't have much loss of energy from the friction in the rope and so on. We don't lose much energy with these, so they're really good for calculating these things. And what we need to now look at as well is not only the period, but we need to look at the frequency and the period and the frequency and how those interact to the cycles. So before I move too far, let's talk about our springs again, because the springs also give us periodic motion. So if I have a spring and I release it, it's going to move up and down. Now, this one, we've seen a transference of energy a little bit side to side, and we've lost some of our energy. So the conservation of energy is not as good in the spring as it is in the pendulum. But we can see that this does oscillate up and down. So once again, if the up position is where I wish to think as my starting point, then one cycle, it would be down and then back up as a cycle. Down, back up as a cycle. And it doesn't matter if I start in the down or the up, or maybe even in the rest position. With the pendulum, the rest position was very similar. It's, I had here, I had there, but the middle is the rest position in a pendulum. So there we go. So I have a periodic motion from my spring with this mass. So let's start by beginning and looking at some of the things that we can measure with my pendulum or my oscillating spring. First of all, N is the number of cycles. It's the number of cycles. So in other words, when the pendulum goes over and then it comes back, that's one cycle. T, known as the period, so that's important to know that is the period. And the period is the T is the time it took divided by the number of cycles. All right, delta T, well, that's just our change in time. And F is the frequency. It's commonly written as a lowercase written f, but I'm okay if you just use F. But F is the frequency. And what the frequency is, I'll put some words up here with time as well. Frequency is how far does it go in 1 second? Whereas the period is the time for one cycle. Okay? So time for one cycle is the period, and how far does it go in 1 second is the frequency. So our frequency can be calculated two different ways. Well, it's basically the inverse of our period. So the frequency is the n divided by the change in time, or, and this is the most commonly used one, that the frequency is the inverse of the time. Likewise, time is the inverse of the frequency. Now let's make sure we got our units figured out here. The units of time are in seconds. However, the units for frequency is the inverse of that, so it's per second. Or it might be written that way, or we give it the special name of a Hertz, HZ, named after a very famous scientist. So the question I have here is, we have a pendulum that swings 10 times. So what this is saying that n is 10. And then I see that it goes 25.7 seconds. So that's my change in time. My change in time is 25.7 seconds. And I want to know the period, and I want to know the frequency. Well, that's easy enough. Two different ways I could do it. So first of all, t is my delta t over n, which is equal to 25.7 seconds divided by 10. I don't even need a calculator for that one. I see that t is 25, oops, not 25, it's 2.57 seconds. All right, my frequency, I could either do it as 10 divided by 25.7 seconds, or what I could say is that my frequency is the inverse of the time. Either works, and what you're going to find here, frequency here is going to be 0.389 seconds to the negative 1, or I might say 389 per second, or the most common one we're going to see is 389 hertz.